Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we are going to continue talking about graphing quadratic functions. Yesterday we learned how to graph quadratic functions using properties, finding the axis of symmetry, which is x equals negative b over 2a. Then plugging in that value of the axis of symmetry into the function and finding the vertex. Then finding the y-intercept, using the axis of symmetry to find mirror images. And last but not least, if they ask you to go ahead and solve the quadratic function by either factoring and using the zero product property, completing the square root method, or when in doubt, the quadratic formula. Now today we're going to talk about graphing quadratic functions using transformations. And when we're using transformations, we're using a different form of the quadratic function. When we were using properties, we used the standard form, which is y equals ax squared plus bx plus c. Here we're going to use a different form. We're going to talk all about it. Now, before I can talk to you about transformations, guys, every single function, okay, every function works with transformations. It's just a matter of whether or not you put it into standard form or if you put it into vertex form. So everything that I'm teaching you today, guys, works the same for every single function. Square root function, yes. Cube root function, yes. Cubic function, yes. Irrational function or rational functions, yes. Any function this is going to work with, okay? So without further ado, y equals ax squared is the parent quadratic function. You could use this with any function though, okay? If you want the parent function will be y equals a times the function that is in question, okay? Times the basic function that is in question. In this case, it's a quadratic, and the most basic part of a quadratic is the fact that you have an ax squared. So when we go ahead and do this, okay, we're going to graph the most basic of all, which is just literally y equals x squared, where a is 1. So if I make a little table here, guys, let's go negative 1, 0, and 1. When x is negative 1, y is 1. Y is y. Y is 1. When x is 0, y is 0. And when x is 1, y is 1. So my parent function of a quadratic is this right here. And if you want, we can even get more technical. Let's go 2 and negative 2. And then it'd be 4 and 4. So 2, 1, 2, 3, 4, and negative 4. And that is the parent function of a quadratic. Any quadratic function that you see from now on is a manipulation of that graph right there. It was either stretched more vertically, compressed vertically, shifted to the left, or shifted to the right. But this is the parent function of any quadratic function. You don't need to learn all 4 points, but for sure, memorize the first 3. These guys. Okay? Negative 1, 1, 0, 0, 1, 1. Or make a little table. You find your parent. Does everyone understand how to find the parent? Okay? It's y equals ax squared. When a is 1, this is the most basic of quadratic functions. Now, the vertex form of quadratic functions, guys, is a manipulation of the parent quadratic function. And it equals y equals a times x minus h squared plus k. If anyone recalls, we talked about the a, the h, and the k when we did absolute value functions. But don't worry, we're going to talk about them again. All right? And we talked a little bit about the a yesterday. We're going to talk about it again right now. So right now I'm going to go through a series of just simply explaining what the a, the h, and the k does, how it affects the quadratic functions. Are you guys ready? Awesome. Okay. So y equals a times x minus h squared plus k. The a is very important when analyzing a quadratic function. Guys, if a is positive, then the parabola points upwards. I don't care what the value of a is. If it's positive, your graph will be pointing, whoa, your graph will be pointing upwards, period. It's just the way it goes. Always 100%, just no doubt. If your A is positive, it points upwards, period. If A is negative, it will point downwards. I don't care how wide it is or where it was shifted. If your A is negative, it will point downwards. We talked about this yesterday as well, so that's why I'm going kind of fast with this. Now, when we're talking about the absolute value of the A, now is when we get into very important stuff. And wait, hold one thing. I sometimes forget to mention this. When A is negative, so for example, let's say I have, sorry about that. Let's say I have y equals negative, whatever, 2x squared plus 5, okay? When you have a negative, okay, you have a negative A, that is a reflection over the x-axis. Let's think about that statement. When you have a reflection over the x-axis, that means that you're multiplying the y values by a negative. So when I originally had, let's say, 2, 5, the reflection over the x-axis of that would be 2, negative 5, okay? No, your parabola is going down. That's why it's going down. If I have a positive graph, my man, okay, I have a positive A, it's like this, okay? But now, if I have a negative A, it's a reflection. It's upside down. It reflects. It's a reflection. So for example, this point right here is 1, 2, 3, 1, 2. This point right here is -3, -3. Okay? When I reflect that over the x-axis, the y is going to change. Watch what happens. This guy here, when I reflect it, well, this isn't really a very good representation of that because it's not exact, but the reflection of this would be -3, 3. So it'd be -3, 1, 2, 3, 1. It'd be here. That would be the reflection of that point. Correct. Okay. So that's what a reflection is. So when I have an A is negative, it's a reflection over the x-axis. Now, when A, the absolute value of A is greater than 1, guys, I have what's called a vertical stretch. The graph becomes narrower, and I will prove it to you. We know that y equals x squared. My parent function is 0, 0, 1, 1, and -1, 1, and that's my graph. Okay, cool. Now, let's look at it when I have an A of 2 here, guys. Let's make a little table. -1, 0, and 1 again. Well, -1 squared, so we got 2, 0, and 2. So we got 0, 0. That's fine. We'll do it in blue. But then I've got 1, 2, and -1, 2. Guys, all joking aside, do you physically see how that is narrower, how it's thinner? Well, that's why it's called a vertical stretch. Kind of like when you elongate a rubber band. Check it out. Look at this rubber band right here. If I have a vertical stretch, doesn't it become thinner and thinner, more narrow? So as A, the absolute value, I don't care if it's pointing up or down, as the absolute value of A becomes larger and larger, greater than 1, I have a vertical stretch, okay? And I'm getting thinner and thinner. Next, if the absolute value, I don't care if it's positive or negative, but if the absolute value of A is greater than 0 but less than 1, it's between 0 and 1, in other words, it's a fraction or a decimal, I'm going to have a vertical compression. It's going to get wider. I'll prove it. Y equals x squared. It's right here. And now, let's find out what y equals 1/2 x squared would look like. And actually, you know what? I should have done that. Kept the color coded here. Sorry about that. Red is the parent. Okay, now in blue, we'll do this guy. Okay, so let's make this easy. I'm going to choose values of 2, -2, and 0. Because 2 squared is 4, 4 times 1/2 is 2, -2 squared is 4, 4 times 1/2 is 2, and 0, 0. So I got 0, 0, 2, 2, and -2, 2. Do you guys see how that is wider? You with me here, guys? So A is super powerful. If A is positive, it's pointing up. If A is negative, it's going down because it's a reflection over the x-axis. If the absolute value of A is greater than 1, I get narrower, okay? It's a vertical stretch. I get narrower. If my A is between 0 and 1, if it's a fraction or a decimal, my graph gets wider. It's a vertical compression, okay? You feel me here, guys? Okay, let us continue. Now, the H. All right. The H, guys, H stands for horizontal, okay? If you have in your function, you see an x plus h, that means that h is negative. Think about that. I have x minus h. So if I have x plus h, didn't that mean that h had to be a negative? Because a negative times a negative is a positive. So if I see an x plus h, that means that h is negative, and I'm going to shift the graph to the left that many spaces. So literally, my function here is y equals x squared as my parent. So 0, 0, 1, 1, -1, 1. When I have x plus 3, that means I'm shifting it to the left that many places. So every point gets shifted 3 to the left. So I'm going to go 1, 2, 3 to the left, 1, 2, 3 to the left, and 1, 2, 3 to the left. And it's the same exact graph, except it was shifted to the left 3. Why to the left? Because when you have x plus an h, you know that the h was negative. Exact opposite for when it's x minus h. If you have x minus h, that means that the h, whoa, sorry about that. That means that the h is positive. And if the h is positive, that means you shift the graph to the right. Again, my parent function, 0, 0, 1, 1, -1, 1. But now I have a -3 here, so I'm shifting to the right 3 places. So I go 1, 2, 3 to the right, 1, 2, 3 to the right, and 1, 2, 3 to the right, and bada bing, bada boom. This time I shifted to the right 3 places. Does that make sense, guys? Yes? Okay. Next, K. The K is a vertical shift either up or down. There's no opposites. If the K is positive, you shift up. If the K is negative, you shift down. So let's prove it. My parent function, y equals x squared, we got right here. And now I've got y equals x squared plus 2. Notice it's not with the x in parentheses, it's outside of the x. That's why it's the K. So I'm literally going to shift every single point up 2. So I'm literally going to go up 1, 2, up 1, 2, and up 1, 2. It just shifted up 2, the whole graph. And when k is negative, you shift down. Again, let's prove it. My parent function, 0, 0, 1, 1, -1, 1. Now, I'm shifting this down 2, so I'm literally going down 2. So I go down 1, 2, down 1, 2, and down 1, 2, and it's the same exact graph. It's just shifted downwards. Make sense, guys? Not bad, right? Okay, now, let's put this together. I want to graph x plus 2 squared plus 1. Okay, guys. I got two ways to do this, all right? I think they're both easy. I think they're both worthy of being taught, and I definitely need you to decide what you want to run with, okay? The first method that I'm going to teach you is going to be I'm going to open up a new page for it. The first one is what we've already learned. Let's say that I want to graph this same exact function, y equals x plus 2 squared plus 1. Okay, I want to graph that. Well, guys, this looks like a quadratic function, but it's been shifted, correct? So you could always graph the parent and shift. Okay? Graph the parent and shift. So what am I talking about? Let me show you. So my parent we know is 0, 0, 1, 1, negative 1, 1. If you don't know that, please go ahead and make a little table. That's my parent. Guys, how was this graph shifted? No, 2 to the left and up 1. Remember, they're opposites, guys. When you have x plus an h, that means you have a negative h, you go to the left. So these points are shifted to the left and up 1. To the left, up 1. To the left, up 1. So 1 to the left, up 1. 1 to the left, up 1. 1 to the left, up 1. This red guy right here, that's my new shifted graph. Does everyone see that? That is, hands down, a nice, easy way. I don't like it, me personally, because you have to graph two functions. You have to graph the parent, then you have to shift it, okay? But that is definitely a way to do it. There's not a darn thing wrong with that. That works. That's kick butt. That works with any function, by the way. Graph the parent and then shift. Graph the parent and then shift. Graph the parent and then shift. Remember, make sure you know what your A is. In this case, the A was 1. Now, that's one way. The better way, in my opinion, is A. Find and graph the vertex. So guys, let's find and graph the vertex. Where is the vertex here? What is the vertex here? The vertex is my H and K, correct? My H and K is my vertex. So when I want to find the vertex and graph it, it's negative 2, 1. Why? My H is negative 2 and my K is 1. My HK is my vertex. So I go to negative 2, 1, and that's my vertex. Everyone see that? Now, guys, what invisible line is going through that vertex? The axis of symmetry. So don't you have an invisible line going through here that's cutting it in perfect half? So everyone's with me here, right? Okay, now, step 2. Find and graph the y-intercept. Guys, the y-intercept is not 1. Be careful. The y-intercept is the c value if and only if it's in standard form. Here, to find the y-intercept, you got to make x 0. When you make x 0, 0 plus 2 is 2. 2 squared is 4. 4 plus 1 is 5. So 0, 5. So I go 1, 2, 3, 4, 5. Now, you ready? Because this is the easy part now. So 1, 2, 3, 4, 5. Guys, mirror image. Mirror image. Okay? Whoa. Whoa. Let me just, hold on. Don't worry about it. So if I have 2 to the right, where's my mirror image? 2 to the left. And guess what, guys? I'm done. Done. Cake. Now, if the vertex and the y-intercept are the same, we talked about this, right? Plug in any value for x, find the corresponding x value, and then plot the mirror image. Then graph the ordered pair you found along with this mirror image. Or you can solve, which again, I've repeated this 100 times. You can solve by factoring, completing the square, quadratic formula, or square root method. In this case, does this have any solutions? Guys, does this have any solutions? No, it doesn't cross the x-axis. There are no solutions here. No real solutions. The complex solution, then you'd have to actually use the quadratic formula. You have to use the quadratic formula. Okay. You guys with me here? Promise? Now look, to answer your question better, if I wanted to find the solutions here, I make y 0. And actually, I wouldn't have to use the quadratic formula here. You got plus 1, subtract 1 to both sides. Negative 1 equals x plus 2 squared. How do we cancel out? That's right, take the square root. Oh boy. Take the square root. So this is going to be I plus or minus equals x plus 2. Subtract the 2. So x equals negative 2 plus or minus I. I knew it was going to be complex because it did not touch the x-axis. Thank you so much, kid. This makes sense, guys. So I don't know which one you want to use, and I'm not being sarcastic. I don't care. I really don't care. Figure out the one you like, though, and run with it. You like the parent and then shifting? Perfect. Do it. You like recognizing the vertex in 2 seconds, finding the y-intercept, finding the mirror image? Do it. I don't mind. But you guys definitely got to choose, okay? Now, okay, guys, here comes the fun part of the day. All right. Now, guys, graphing it is really simple, all right? Especially when it's in vertex form. But the whole key here, guys, is learning how to write a quadratic function that's in standard form, how to write it in vertex form. Now, I know that you guys didn't like it too much, but we learned how to complete the square. We're going to have to use that skill to solve into vertex form. So let's get right to it. I want to write y equals x squared plus 8x minus 5 in vertex form. Okay? I'm writing y equals x squared plus bx plus c in vertex form. Y equals a times x minus h squared plus k. Step 1. Separate the c from the x squared plus 8x. So literally just separate it. Don't bring it to the other side. Just separate it. Okay? So all I did was I'm separating these two guys. So on your paper, you may have even gone like this, giving yourself some space. Okay? Separated it out. Step 2. Guys, I'm going to go ahead and complete the square. And this time, remember how I would add b over 2 squared to both sides? Okay. I added b over 2 squared to both sides because I was solving. But in this case, I'm leaving my y alone. Okay? I'm leaving this y alone. So just think about this logically. If I added b over 2 to this side, and I want y alone, don't I have to subtract my b over 2 squared back to the other side? Guys, if I added my b over 2 squared, but I want to solve for y, don't I have to bring this b over 2 squared back as a negative? Does everyone see the logic there? Okay, because that's what's happening. I have my b over 2 squared here. My b over 2 squared is going to be 4. So please pay attention to what I'm saying, guys. Subtract the b over 2 squared from c instead of sending it to the other side of the equation. So I have my b over 2 squared, which is 4, and I'm subtracting it from the c. And then, guys, you're done. How do I write this guy right here in perfect square? What did I teach you? What's the trick? Go ahead. Come on, say it. Right? Y equals x plus 4 squared. And then what's negative 5 minus 16? What's it going to be? Correct. Negative 21. So, guys, was that really that hard? It's actually not that bad at all. Now, are numbers always going to be pretty and beautiful and sweet like this? No. But that's why we're going to train with these numbers. And then later when it gets harder, We do it. Okay? I'm going to give you now another example, and then I'll teach you the second type of problem that you have to turn into vertex form. But right now, I'm just going to first give you a new example. Let's go ahead and write y equals x squared, let's say plus 6x minus 3 in vertex form. So step one, my brothers, isolate those two guys. Step two, complete the square. So x squared plus 6x plus b over 2 squared. B over 2 here is 3 squared. So you have the minus 3 minus the b over 2 squared. Let me stop right there. Do you see what's happening here, guys? This negative 3 drops. This right here is minus b over 2 squared. Whatever you added here, you have to subtract here. You have to. And now it's easy. Y equals square root of the first term plus the inside part, which is 3 squared. And then negative 3 minus 9 is negative 12. Questions, comments, concerns, problems, issues, dilemmas, talk to my brothers. Please, please, and please talk to me. Yes, sir. Thank you. Or what do you mean cancel out the b over 2 squared? No, this is inside of here. That's outside. No. Yeah. And now from here, guys, what's my vertex? Negative 3, negative 12. Yes. What's my y-intercept? It's not negative 12, guys. When x is 0, what's 3 squared? What's 9 minus 12? Negative 3. So, guys, you see you have your vertex, your axis of symmetry. You put your y-intercept, mirror image, you're done. You with me here? Are you sure? I got to complicate one more thing. Are you ready for it? I believe in you. Let's do this. All right, guys, last but not least, I promise. I know it's been a long lesson. You guys have been amazing. I just want to say thank you. Y equals, I want to write y equals negative 3x squared plus 6x minus 1 in vertex form. Okay, so now I'm writing a y equals a x squared plus bx plus c into vertex form, which is y equals a times x minus h squared plus k. What you have to do here, guys, the good news, it's almost identical to the first type. The only difference now is that you have an a. If you guys remember when we were solving when completing a square, you had to divide everything by a. This is similar, but not exact, okay? This is similar, but not exact. Step one, what you are going to do, guys, is you are going to separate the c from the ax squared and the bx. But then you're going to factor out an a only from the ax squared and bx. Only from the ax squared and bx. You're going to factor out the a only from the ax squared and bx. You're not going to touch that c. Do not touch that c. So what the heck is Mr. Morrow saying? Mr. Morrow is saying this. I separated these guys. That's why this guy's isolated, right? But then I took out a negative 3, right? When I factor out a negative 3, pulled out my negative 3. Negative 3 divided by negative 3 is x squared. And then 6 divided by negative 3 is negative 2x. Are you with me here? Now, this c that I pulled out, I have to subtract it from c as well. Just like you have to subtract the b over 2 squared, you got to subtract this a as well. Now from here, yes sir, thank you. Yes sir, my brother. Okay, thank you so much, because I'm subtracting the a that I factored out. Didn't I factor out a negative 3, my brother? I'm subtracting what I factored out. So I'm subtracting the a. that I factored out. You feel me? Thank you, brother. So now we're going to complete the square, just like before. And we're going to add b over 2 squared to complete the square to the factored out a, though. We're going to go ahead and multiply that sucker. So we have to have the b over 2 squared, but that b over 2 squared we have to multiply to the a. So we have negative 3 times x squared minus 2x. The negative 2 is the b. b over 2 squared is the negative 1. I've got to multiply that to my a. So this part right here, guys, is minus the a that I factored out times the b over 2 squared. That's where those values are going. And then from here, complete the square and actually literally solve and simplify. Factor the perfect square, simplify, and write in vertex form. So it's going to be negative 3, x minus 1 squared, and then I have a negative 1 minus a negative 3 times a negative 1 squared, which will equal negative 3 x minus 1 squared plus 2. Trust me, guys, I know that some of you are like, what the heck? You're going to have to watch this video again. And I have time to do one more just to flow through it all so you can see it in action one more time. Okay? Don't be afraid. You can do this. Believe in yourself because I know you can do this. All right, I know you want to get to lunch. Let's go ahead and write y equals, I don't know, let's say, let's go 5x squared plus 10x minus 7. I want to write that in vertex form. Okay, here we go, boys. First things first, separate these two guys and factor out the a from the first two terms, the x terms only. So I have 5 times x squared plus 2x minus 7 minus the a that I factored out of 5. Is everyone with me? Now complete the square. Plus b over 2 squared. 2 over 2 is 1, so 1 squared. I got to multiply that to the a. Is everyone with me? And now it's Mickey Mouse time. 5x plus 1 squared. And then I've got negative 7 minus 5, so that's minus 12. And ding dong, the witch is gone. Does that make sense, brothers? It's not that bad, is it? It's procedure intensive, yeah, but it's not that bad. I know you can do it. Homework is valid. Thank you for a great class. God bless you all, and I hope you learned a lot today. Have a great day, boys. Thank you.